Hi guys, in our earlier video we had looked at the reaction between an alkene and of course water, which was taking place in the presence of an aqueous acidic solution. So therefore today we are going to look at one of the reactions in organic reactions that basically deals with the concept of hydration of alkynes. So therefore in this particular case we are going to confine ourselves to this particular functional group. And we're going to achieve that using one of the examples that we had mentioned in our earlier video. So I'm going to use this general illustration for this specific reagent, which is an alkyne that is undergoing hydration. And we said that this is basically the addition of water or the OH and H positive groups across the triple or double bond. And this is going to take place under aqueous acidic condition, as I've illustrated. So if we try to look at that specific reaction, then therefore we're going to have this one forming an alcohol. And the first step that is going to lead to the formation of an alcohol at that specific point. So therefore, if we try to look at this, these are the two methyl groups that are going to be formed at this specific point, and we're going to have a H group being attached. So basically, from the concept of hydration that we had looked at in the first reaction for alkenes, we had said that the hydrogen group and the OH group is going to be attached across the double bond. And in our first case, that one led to the formation of what we refer to as a phenol dihalide, whereby we had considered a protic acid that consisted of a hydrogen and basically a X group, which was a halide, which was having a similar reaction to the concept of hydration. So basically that one, we're going to have it in a different video, but this is going to take the similar approach, whereby for alkynes, we're going to see that this step is going to be followed by a first reaction, which is going to lead to the formation of another functional group that we call the ketones. So therefore, we're going to have this one being illustrated as this, whereby we're going to have those two methyl groups attached at those specific points, just for the sake of emphasis. So therefore, if you try to look at this specific reaction, therefore, in hydration reactions, when it's consisting the functional group of an alkyne, this is going to take place in two steps, whereby the initial reaction is going to lead to the formation of an alcohol, and that reaction then therefore is going to proceed further and lead to the formation of what we refer to as a ketone. So therefore, this is an alkene functional group. Therefore, we are going to refer to that one as an alkenol, and this is an alkyne, and this is a ketone. So therefore, we're going to have similar illustrations using that specific example. Now, insofar as the arrangements are concerned for the product, we are going to consider that one in another video, and perhaps we can be able to look at one of the examples and try to contrast it with what we have looked at using this specific rule. So if therefore we have a reagent which is this particular reagent, so this is for 1 and 2. So if we have a reagent for 2 that is undergoing hydration, this is going to lead to the formation of still an alkanol, which can be illustrated as this. So therefore we're going to have a OH group attached at that specific point, and this as well is going to be analogous to the first one, whereby we're going to have this reaction proceed at a faster pace. So this is a methyl group. So first, and this is going to lead to the formation of a ketone as well, which is basically going to be illustrated as such. So therefore, if we try to consider these two basic groups, this is the reaction that is going to occur. And of course, we're going to see that the reaction mechanisms that is going to involve this particular case basically is the reaction between the carbon-carbon triple bond functional group with the hydrogen group that is going to lead to the formation. It's going to pick on the proton that is going to lead to the formation of this intermediate, and therefore for the subsequent reaction is going to involve the water molecule that is going to attack at this specific point due to the influence of hydrogen that had brought in the partial positive charge. So therefore this is going to act as an electrophile, whereby this is going to act as an electron-rich species that is going to attack on this second carbon, therefore leading to the formation of this final product. So this reaction mechanism is basically analogous to the first one that we had seen on hydration of alkenes. and therefore we're not going to consider that one. And I'll put a link of this first video in the description box so that we can be able to check on it and perhaps try to have an understanding of that specific reaction mechanism. So catch us in our next video where we're going to look at the halogenation reaction. And basically, as I had mentioned, this is going to have the same rearrangement that we're going to see that is being illustrated in the hydrogenation or rather the hydration reaction for both alkenes and alkynes respectively. So that is it for now, guys. Bye. Catch us in our next video. God bless you.